Hello, I'm back now. Hello, Swapna, are you there?
Yes, Krish.
Okay, so now let's see us another model, and this model we are trying to build in order to reduce our forecasting error or improve the forecasting accuracy. So, what is the difference between moving average and the weighted moving average? That's the first concept we need to understand. So, the weighted moving average and moving average, right? Moving average, what we do is we simply take the average of three numbers. For example, this is A plus B plus C. The three numbers. So what is the denominator in the case of average? Since there are three numbers, the denominator will be 3. Right? Moving average, A plus B plus divided by 3. Because there are three numbers, we will divide by 3. If there are four numbers, what will denominator?
4.
4. Right? So like this, we work with the moving average. But see, what is the beauty? What is the important thing to note over here is that if it is four numbers or three numbers, whatever it is, if I break this, it will be like this, right? A by 4 plus B by 4 plus C by 4 plus D by 4. So this is A plus B plus D is a sum. We are dividing by 4. So what we'll do? If we break this bracket, it will be like A by 4, B by 4, C by 4, D by 4.
Yes.
So what is denominator here? What is a factor here? The factor is 1 by 4. Is the weightage factor for A, B, C, and D. In each cases, 1 by 4 is the factor. Suppose if I again write in a different way, this will be 1 by 4 into A plus 1 by 4 into B plus 1 by C into D plus 1 by C A, B, C, right? A, B, C, okay. 1 by 4 into C, 1 by 4 into D. And what is the beauty of this? The beauty of this is if you add all the factors, what is the sum of the all the factors? Sum of all the factors, 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. What is the sum of all these factors? That is 4 by 4 equal to 1.
1.
There are two things are important to note here. One, the first thing is that each number has the same factor. That is 1 by 4. First thing. And second thing is, the second thing note is that the sum of the factors is equal to 1.
Yes.
Each number has the same factor. That is 1 by 4. And sum of the factors, sum of the weightage factors is equal to 1. This is what happens in moving average. Now, what we can do in weighted moving average? Different. So, difference is suppose if it is A by A plus B plus A, B, C, D are there, right? I will not give them equal weightage. Like here, 1 by 4 is 1 by 4, 1 by 4, 1 by 4. We are giving equal weightage to each of these
Yes.
numbers. Now, in this case, what I will do, I will give suppose 1 by 2 to A. I'll give 1 by 3 to B. Okay, I'll give suppose 1 by 5 to B, C. And how much I'll give to D? So that I can do one calculation, that is 1 minus. Why 1 minus I am doing? Because sum of the all the weightages should be equal to 1.
Equal to
1 by 2 plus 1 by 3 plus 1 by 5 right? And I have to find the next weightage for the D. That is equal to X, right? This is what I have to find. So how to find that? So we know that sum of the weightages is equal to 1. What is X equal to then? X is equal to 1 minus within bracket 1 by 2 plus 1 by 3 plus 1 by 5. If we do this calculation, we get the weightage for the D also. So if I do this, is equal to 1 minus within bracket 1 by 2 plus 1 by 3. So very simple, 1 by 5, right, within bracket. And I am getting how much? Minus 0.033. It means the weightage of 1 by 2, 1 by 3, 1 by 5 is more than 1. If I do this, 1 by 2 plus 1 by 3 plus 1 by 5, how much is getting? This is 1.033. It means the sum of the weightage of 1 by 2, 1 by 3, 1 by 5 is more than 1. It should not be more than 1. So if I will do, what I'll do here is I will put instead of 3 or instead of 5, I'll put 2. Okay, so here I'll put instead of 5, I'll put 2. I'm getting now 1 by 3. So 1 by 2 plus 1 by 2 is again 1. Sorry, 2 by 2, 1. So let me put here 1 by 3. Again, we are getting high number. Let me change this as 1 by 4. Again, we're getting a high number. Let me put this again as 1 by 4. This is 0.16, right? So we're getting 0.16. So this is X is or 0.16. So this factor is, the last factor is 0.16 into D. Like this, we can find the factors, and each factor is not equal in the weighted moving average. In the case of moving average, each factor is equal. But in the case of weighted moving average, the factors are not equal. And why we do this? The question is, why we take different factors? The reason why we take different factors is because, are you there?
Yes, Krish.
So why we take different factors is because, in sales, sometimes we have to give more importance to the first period sale or less importance to the fourth period sale, or we have to give more importance to the fourth period sale and less importance to the first period sale, or we have to give more importance to the second period sale or third period sale. So whichever period sale we have to give more importance, we'll give more weightage.
Okay.
That's why we are going for weighted moving average. But in the case of moving average, this is not possible because we have to give same weightage to each of the periods sales. For all the period of sale, we have to give same weightage. But that is what we are changing now. We are going to give different weightages now. So let's do that. So what I will do is that I will write the weightages number here. So this is my weightage 1. This is my weightage 2. This is weightage 3. And this is my weightage 4. So I'll just give me, suppose I want to give more weightage to the period number 3. Okay. So my highest weightage will go for this 0.5. I want to go the least weightage to period number 1. I'll give 0.1. Okay. This is, I'm putting random numbers, but we will optimize this using a mathematical model later. So I am just, by looking at the data, my guesswork is that I have to give, see, if you look at third period 821 here, the third period is how much? 821. What is the third period here? 1269. right? By looking at these numbers, what I'm seeing that okay, we need to give more weightage to the third period.
Third period.
And if you look at the first period is 201, here the first period is again 24, fifth, right? So what I'm saying is that the first period has to be given lower weightage. Okay, so fourth period, and then I'll go to fourth period, and fourth period I'll give third period, I'll give second period, I'll give more weightage now. This will be equal to 0.1, 0.2, 0.25, sorry. So how much we have to give for the fourth period? That is 1 minus this, because some of the weightage has to be equal to 1.
Equal to 1.
So this plus this plus this 0.15. If I do sum of all these numbers, it should come 1.
Okay.
And we're getting 1. Very important point which we have to remember if you're doing weighted moving average, because if the sum of the weightage is not equal to 1, then I think we are going to get erroneous results. That will not be called as average. If the sum is not equal to 1, sum of the weightage is not equal to 1, then that will not be called as an average. Okay, that will be called a weighted forecast, but it will not be called as weighted moving average forecast. Now I'll start doing a forecast. So what I'll do, I'll take the first value, that is G5, and multiply it with the first weightage, and I'll freeze this number. Plus I'll take the second sales value and multiply it with the second weightage, and I'll 0.25, and I'll freeze this. I'll get the third value and I'll multiply that with the third weightage, and I'm going to freeze this.
0.5.
I'm going to take the fourth value and I'm going to I'm going to fourth value, I'm going to multiply that with the fourth weightage, and I'm going to freeze that. This is my weighted moving average forecast for 4 periods. And if you look at here, the last value, if you see, this is a forecast of only 3 periods, not the 4 periods. We want forecast for 4 periods, but if you look at the last value, which is not available here for us, so we will remove this number from here. Look at the last value again now here, and the last value is in this case it is a weighted moving average for 4 periods. So we have to know where to stop. We have to know where to start, and we also have to know where to stop. If I drag this number from this point to this point, and what I see here is this is not the weighted moving average for 4 periods. This is a weighted moving average for 3 periods. But our model is based upon weighted moving average of 4 periods. That's why we have 4 weightages. So check the last value whenever you do when you drag the formula. When you drag the formula to the last point, you have to check go and double click on the last point. And if you double click on the last point, and if you see that last point has 3 periods or 2 periods, you have to delete that particular forecast value from the model. Okay, so this is important thing over here. Now we got our weighted moving average, and if you have any questions, please let me know. Or else I'll move forward. Now we are going to calculate your forecasting error.
Yes, Chris, why this first value you have left, and that once again, can you please?
See, generally what happens is if you do what is average? What is average? Average is a central number, right? Average is central number. So I am taking these are my first 4 values, right?
Okay.
So where is center of these 4 values? It will fall between 535 and
And
821. So I cannot put this number in between them. I have to put either on the first value or the second value.
Okay.
Either I have to put on 535 or I have to put
820.
821. So what I've chosen is I decided to put it next to the 535. The reason why I have put next to 535 is that I can get additional value, additional forecasting value. Suppose if I start this forecasting from here, 821, okay, this into the first weightage plus this into the second weightage
0.5
plus this into the third weightage plus this into the fourth weightage.
339 trays.
Okay, so now we got 615 here, the same value which you got on the top, because this 615 is average of these four values, and 615 is also average of four values. Now what happens? See, if I drag these numbers up to this point, I go to 994, right? See what is happening?
Yes.
I'm getting up. I have to stop up to 994. If I drag this value further down, what will happen? I'm getting average of three values. And see, and this 561 is coming down, but this 561 is in the second.
No, the above one.
So if you have to start, if you can start from here also. If you want to start from here, you can start from here also.
Okay.
And there is one more thing. There are some people also start from here at the end of the four values. For 1, 2, 3, 4, we find the average at this point. There are some formulas, some people who start from here also.
Okay.
So here, if I do this into,
so it's better if we start from second or third, Krish?
You can start from second or third. Well, you can check the model. You can check the model based upon your, you can check. Let's check all the models, right? We'll check all these three together and see which one is coming good.
Okay.
So this into this. See, there is no in analytics. There is no rough rule. There is no standard rule. Everything what you need to do, you need to have methodology. You need to have a methodology, and based on that methodology, you have to go with. We should not be opportunistic. We should not be opportunistic in analytics. We need to be very much we need to have methodology for our approach. So now if you look at here, I'm going to do this one, and I have to stop it. Let me drag one more value, 600. Again, I can drop here one more value, because so this is the last I can go, right? I cannot go beyond this because this is the last historical value. So we have taken we have given three different positions for weighted moving average. One at the second, one at the third, and one at the fifth. And let's find the. Let me write this is weighted moving average 4 periods, and I'll write this is 1. This is first model. This is second model. I'll write here 2. This is my third model. I'm going to write here 3. And let's find the error for all the 3 models. Here we are going to find this 615 minus 535. Now we are going to find our error for the second model, and I'll just find the absolute error here first. And then I'll find the absolute error, percentage error also I'll find here. So this is absolute, this is 80. And I'm going to find the absolute percentage error now. That's I'm going to divide this 80.2 by the sales, same period sales. Right, and then I'm going to do what I'm going to do. I'm find the absolute percentage error, mean absolute percentage error. And for that, I'll find the average of this. All right, I'm see we're getting 2.78, and this is 2.78 means how much? This is 279%. Okay, this is 279%. Now what I'll do is I'll find the absolute percentage. I'll find directly the numbers. I'll not do stage by stage. I'll just directly find this for the second model also. The second model we do this here equal to ABS, and that is your second model number. This minus this same period average, and I'll divide this by the sales history, and if I do this, I'll get my value absolute percentage error. For the model number 2. And I'm going to do the same thing here also. I'm going to find the average. Let's see how much we get here. This is 1.59. So this is the reduction now. Right? From 279%, you're getting 160% absolute percentage for model number 2. Right? Then I'll do the absolute for model number 3. Let's see how much we get. And that position is after here, right? This is again I'll do equal to ABS. This is 615 minus 24 divided by 24. I'll close the bracket. I am getting 24.63 here. I'm going to drag till the last point. Okay, and I'm going to find the average again. You're getting an even higher value in the last case. That is 371.
That is 2.27 is not okay. That is also there, Krish. 2 point last value.
Yeah, is there. So this is our mean absolute percentage error, which we got after applying the 3 models. 3 different same moving average, weighted moving average. Just we change the positions. Nothing else we did, right? We just change the positions, and after changing the position, this is what we are getting over here, right? Now, the numbers which we have chosen initially, these weightages, right? They are not optimized. They are not the best numbers. Okay, they're not the best numbers. So if I have to make these weightages as the best numbers to choose, so that my error is optimized, for that what I will do is that I'll use a functionality of Excel, data. I'll go to solver. Okay, and I'll choose this as my objective, and I have to reduce my error, right? I have to reduce my error means I will do minimization. What is MIN? MIN stands for minimization. So I have to reduce my error. That's why I would minimization of it. So what are my variables here? My variables are these 4 values. I want Excel, this solver, to change these 4 values, to change these 4 weightages and give me the least error.
Okay.
And then I'll add a constraint here. The constraint is that this should be equal to 1. Okay, and also I have to use a constraint here. These 4 numbers have to be greater than equal to 0.
Okay.
Okay, and I'll use a method called simple linear programming.
Okay.
And solve the problem and see whether we are able to reduce our error. So this is saying this is not we cannot use a linear model here. So what I will do, I'll go back to solver, and instead of using simple linear program, I'll choose another model which is a non-linear model, that is GRG non-linear. Again, let's try to solve. So we are able to see whether we are able to know, we will see whether. So it is saying that 0%. This is a very irradical thing, right? What it is saying is that this is 1. Let's put everything 0. Right? This cannot be possible. This cannot be possible. So we'll go into the solver, okay, and we'll see if we can do something by adding some other adding or deleting some other constraint. What I'll do, I'll delete this constraint from here. Let's see if I, after deleting this constraint, if I get some solution or not.
Solver
Excel,
finds the solution.
yeah, solver is giving the same solution to us again. So I'll run the again, it is giving the same solution. So let me go back to solver and see if I can do something or not. I'll go to add constraint. I will choose these numbers to
Equal to?
not equal to. So we have already chosen this number has to be more than, let's say this has to be different. Let's put this has to be different, and let me solve this again.
Could not find a feasible solution.
Let me put the numbers back 0.125 point. Just I'm putting random numbers and let's see whether we can do something. This is a problem we face every time.
Okay.
So this is 1 minus 1 minus. Let me put a number here instead of formula. 0.15 plus 0.35, 0.35, 0.35 plus 0.25, that is 0.6, and that we put 0.4 here. Let's solve it again. So let me remove this different thing. Sum is enough. Let's see whether we can actually achieve something or not, because last time I had a formula here. Again, we're getting the same thing. I'll go to solver again, and this is sum is equal to 1. Let me add this once again. So this is this has to be more than this. All values have to be more than equal to, let's say 0.1. Point is 0.1. Let's say 0.1. I'm putting. Add here. Cancel. Now let's solve. I'm putting it. All this number has to be more than at least 0.1. Okay, so in this case, what it's showing it is again the same thing. It is making everything 0.1 and giving this as 0.7. And let's see the error, how much we're getting? 95%. It was earlier 279%. Now it came back to 95%. Okay, it is giving weighted, the second period weightage has to be very high. Okay, so now let's do one more thing. I will try to solve one more. Sometimes what happens is if you click on solve again, it changes the values, but it's not changing over here. Now let me again do something over here. So let me change this. Let me put it 1.15 and add here and solve again. So it is 95% now. So how much is now? It is 143%. It has increased. So better we put the last number, that is 0.1. Add it and solve it again. So when I solve it again, now it is showing me 95%. Right? So error has reduced from 279% to 95%. Now what I will do, I'll change my condition, change my problem. So I was trying to optimize my error for the model number 1. Now I'll do the optimization for the model number 2. So for that, I'll go to solver and change my objective here. It is M22. Now we'll choose N22. Okay. So this is how I'm going to solve now. Let's see whether now from 248 it came down to 108.
108.
108, right? Now I'll do the same thing to minimize the error for the third model.
29.
So instead of N22, I'll put how much? 422, and I'll solve the model. See, 429% which is there. Now see how much it will come down. It came down to 186%,
186.
right? So what we are seeing over here is that we are not getting something, a very good result out of this. Even after doing the optimization also, we are not getting a very good result. We want something lesser, very low value. So the weighted moving average is not giving us a very good response. Now see, you're getting 48% error here. So this is how we are trying to build a very good model. Of course these numbers are not the justifiable numbers, because these numbers are over, we are just trying to overfit right now. This is very low weightages. This is very low weightages, so this we are trying to overfit right now. So we have to think about this weightages even further, because this we are trying to do the overfitting. 0.05 is very low weightage. 0.05 is a very low weightage, right? So what we need to do is that we need to even think that why we're getting such a model where we are not able to get a proper distribution of these numbers. So what I'll do, I'll try to change my model, change my method here. From GIS nonlinear, I'll go to evolutionary method. And the evolutionary method, I'll try to solve the same model with the same constraints. Let us see if we get a different result in the evolutionary model. So if you see that at the bottom of the Excel, you will see the iterations happening. So there are different kind of permutations and combinations will Excel will be trying. Okay, and finally Excel will choose a combination of weightages which will generate or provide the least error. So here Excel is going to take some time to do that operation. So we need to wait until the operation is finished, because if we do something or if we close the sheet considering that the sheet is hanged, then we will lose our effort and time. So what Excel is telling that this is the best solution. It cannot improve the solution further. So the weightage 1 is 0.1, weightage 2 is 0.7, weightage 3 is 0.3, and weightage 4 is 0.1. If you go to second model, and if I use my solver and go to and choose my second model, error is an objective. So what we are going to notice here, right now weightage 2 is being given the highest weightage. In the first model, weightage 2 has been given the highest weightage. Let us see what happens in the second model. Which weightage will get the highest, or which factor or which period factor will get the highest weightage? So still it is showing the same second period weightage as the highest factor in the second model also. But it has not done any kind of reduction here. I don't know why it has not done any reduction. So let me check the model once again. What is the, this is N22. So we have M and N, right? N22, G2 to G2 to 1. Let me change it to this GRG nonlinear because it is going to take less time to solve. If you're getting the same results, then it's better to go to GRG nonlinear because it's going to. Now, if you look at here, previously for the first model, we had the highest weightage given to second period. Now, in the second model, the highest weightage is given to the third period. If you go and solve and do the calculation for the last model, and solve this and see which period will have the highest weightage. This is giving the first period the highest weightage. So in the model number 1, the highest weightage was given to second period. In model number 2, the highest weightage was given to third period. And the model number 3, the highest weightage is given to the first weightage. So this is the difference between when we are changing the positions of our weighted moving average. In the first model, we had the second period, second position, where we started the forecasting. In the second model, we started the forecasting with third period. And in the third model, we started the forecasting with the fifth period. So in the third model, we're getting the first period as the highest weightage. In the second model, we're getting the highest weightage as in the third period. And in the first model, we're getting the highest weightage of the second period. This is how the weighted moving average with different positions we can shape. The best output we're getting with the first model. It means when we place the first forecast in the second position. Okay, then I'll be sharing the sheet to you on the email and also on the cloud portal. You can download the file and we'll meet next week, Saturday. And
Okay,
from there,
Krish.
I will go and we'll see more models and more methods to optimize the model. Okay, then see you on next Saturday.
Okay, Krish. Thank you.